Right now, far out of sight beneath the surface, something massive is shifting in the Pacific Ocean. And I mean massive. It isn't just a single storm you can track on a standard weather app. No, it's this slow, incredibly powerful reorganization of energy that's effectively triggering a violent flip of our entire global climate system. Welcome to this explainer. Today we're diving straight into the meteorological data surrounding what forecasters are calling the 2026 monster, a rapidly emerging event that could fundamentally alter our weather, our ecosystems, and our economies. Okay, let's dive into this. According to the absolute latest models, there's now a staggering 98% chance of El Niño emerging by August. 98%! Basically, what this means is that by late 2026, a full-blown Super El Niño is almost inevitable. You know, this isn't just your standard seasonal shift, it's a massive global event, and meteorologists confirm it's already building some serious momentum.
The scale of this thing is truly mind-boggling. We are right on the precipice of potentially the strongest El Niño event we've seen in 140 years. Forecasters are actively warning us that this high-intensity episode will propel global temperatures into entirely uncharted territory. We're talking about pushing humanity way past critical environmental tipping points. We're going completely off the map here.
Let's start with the mechanics of the climate engine, specifically the Pacific Ocean flip.
It all really starts with ENSO, or the El Niño Southern Oscillation. Now, the absolutely crucial thing to understand here is that ENSO is a completely natural cycle. It's like a planetary heartbeat, and it's been thumping along for at least 10,000 years. We can literally see its chemical fingerprints left behind in ancient coral fossils from way before the Industrial Revolution. So at its core, it's just a natural fluctuation of surface temperatures and air pressure right near the equator.
But how does it actually flip? Well, let's walk through it. Normally, you have these strong trade winds that push warm water away from South America, which allows cold water to rise up. But in step one, those vital Pacific trade winds weaken. And as they falter, we move right into step two. Massive, deep underwater pulses called Kelvin waves start traveling thousands of miles eastward. Think of them like giant sub-oceanic conveyor belts. When these waves finally slam into the South American coast in step three, they basically uncork all that trapped oceanic heat, and the cold water upwelling simply stops. The heat is totally unleashed.
Which brings us to a loaded climate spring, when a natural cycle meets a warming planet.
Historical precedents show us that Super El Niños have definitely happened before, right? We saw them in 1982, 1991, 1997, and then again in 2015, which actually featured a record 2.4 degrees Celsius anomaly. But here is the massive catch for our current situation. This time around, we are layering this natural surge onto a planet that has already spent 12 consecutive months above the 1.5-degree warming threshold. So we're working with a much, much higher baseline. It's literally like a loaded spring, just waiting to snap.
To measure the strength of these events, forecasters use the relative ONI index, which takes that increased background warming into account. So a moderate event sits up to 1.5 degrees Celsius above average, while a strong one goes up to 2 degrees. A super El Niño is anything beyond that 2-degree mark. And terrifyingly, the European Center for Medium-Range Weather Forecasts suggests that temperature anomalies could exceed a shocking 3 degrees Celsius by October. That takes us deep, deep into super territory.
Typically, a normal El Niño raises global air temperatures by just a tiny fraction of a degree. But this intense climate whiplash we're looking at, it could drive average global temperatures up to 1.8 degrees Celsius above pre-industrial baselines. That completely obliterates the internationally recognized 1.5 degree safety limit. No question about it, we are looking at the hottest years on record globally.
Moving on to extreme global weather whiplash, bipolar global impacts.
And this brilliantly illustrates just how extreme the split in global weather patterns will be. On one side of the world, coastal Peru, Ecuador, and places like California are going to face catastrophic, unrelenting rainfall. We're talking atmospheric rivers and Godzilla snowpacks triggering massive, devastating mudslides. But then, the complete opposite happens over in the Amazon in Australia. They are bracing for a triad of pressures, punishing droughts, extreme heat, and severe megafires. The Amazon actually faces such an intense thermal stress test that it could permanently switch from being a vital carbon sink into a massive source of toxic carbon.
The oceans face a really similar divergence when it comes to storms, too. In the Atlantic Ocean, El Niño creates high wind shear, which actually tears apart tropical systems, leading to a much quieter hurricane season. But over in the Pacific Ocean, it is completely supercharged. That warm surface water is going to fuel massive cyclones. Just recall the 2015 Super El Niño for a second. We saw an astonishing 16 Central Pacific cyclones, including 3 simultaneous Category 4 storms. It was entirely unprecedented.
So let's look at the true human cost, beyond the weather map.
These shifts trigger a whole set of cascading crises that push us right off the map. In terms of global health, extreme heat induces severe mortality, while floods create stagnant breeding grounds. That allows deadly outbreaks of dengue, malaria, and cholera to expand into totally new regions. Over in agriculture, a failing monsoon threatens vital staples like rice, cotton, and soybeans, and that triggers potential food inflation of 4.5%. Trust me, you will absolutely feel this at your local grocery store checkout. The UN even warns that 318 million people could face acute food insecurity, and this is all happening right alongside the worst global coral bleaching events in history.
When you take all that and add up the lost agricultural productivity, the decimated global supply chains, and the crippling damages to infrastructure and energy grids, the financial blow is practically unfathomable. Historically, events of this exact magnitude have wiped a staggering $3.9 trillion from the global economy in the following years. Trillions with a T.
This brings us to a critical question. A point of no return. Uncharted climate territory?
So the crucial point is that the 2026 Super El Niño is no longer just some distant prediction. It's happening. We are looking at baseline global warming aggressively amplifying a natural cycle. We're watching ecosystems getting pushed way past their tolerance limits. We're facing trillions in economic damage, and we are staring down severe food insecurity for hundreds of millions of people. We're basically witnessing a head-on collision between a natural planetary event and a man-made climate crisis.
The shifts in the Pacific Ocean have officially begun, and our timeline to prepare is rapidly shrinking by the day. It leaves us with one incredibly stark reality to consider. What happens to humanity when our planet's largest natural cooling mechanism is replaced by a global furnace? Thank you so much for joining me for this explainer. Keep your eyes on the data, and as always, stay curious.